So, Streaming müsste laufen, wenn ich alles richtig gemacht habe. Ich prüfe das hier auf dem zweiten Laptop. ähm, Wahrscheinlich ist es mit der Übertragungsbandbreite überfordert. Egal. Ich gehe mal davon aus, dass es funktioniert. Was mache ich heute? Ähm, Ich hatte dieses Video hier gesehen. Ich zeige euch das mal kurz. Ich habe das auch in den Notes verlinkt. Und zwar Pong in 4 Minuten. Das ist von Mike Geig gemacht. Mike Geig ist bei Unity angestellt oder arbeitet für Unity, und er zeigt hier in 4 Minuten in relativ überschaubaren, kurzen Arbeitsschritten mit ganz wenig Scripting, wie man in Unity in 4 Minuten ein Pong-Spiel macht. Ja, deswegen habe ich das als zum Anlass genommen, um einfach mal zu versuchen, das selber zu machen. Natürlich nicht Pong, Pong gibt es ja schon, sondern einfach das zu nehmen, was ich bei Pong gesehen habe, und zu versuchen, ein Breakout-Spiel zu machen. So, and I totally forgot that I wanted to talk in English, since I made this whole video tagged as English. Okay, so I start off with an empty Unity project here. It's Unity 2018.3. Empty project. I got a sample scene, only camera and directional light. So I will start by setting up the scenery. So what do I need for the scenery? I want to have the borders left, top and right, which is basically the field where everything will happen. I need a pedal at the bottom, and I need a ball. So we're doing this all with basic Unity primitives. So I start by setting off the wall. I take a cube. Let's make it a bit smaller and give it a size of 10. And move it to one side. We clone that, move it to the other side, we clone it again, rotate it by, and I'm always hitting the wrong one, rotating it by 90, making it a bit bigger. So to give you a few insights about my experience with Unity. So I have not too much experience with Unity. I think I know my way around when it comes to patching existing code. I tried a little bit around with trying to code my own game, just a small one. I did this video tutorial with rollerball game. I tried a little bit with jump and run, and tried a little bit with 3D stuff, walking around first person, third person, but I never actually finished any project. But I want to finish this one, at least from a small perspective. So we've got the walls. We need the bumper at the bottom. We need a ball. Also makes the bumper smaller. Give it maybe scale of 3. Make the ball smaller. put it to 0.5, we can still see it, but it's smaller. Okay, so move the ball right onto the sphere. So one thing that you can see here is we are actually working in a 3D world, so all of those are 3D objects, so you can see them in 3D. For this type of game, which basically is not a 3D, but the whole gameplay is just 2D. I mean, it looks like 3D. Where is it? I lost it. Anyway. But it's a 2D game. So to avoid the look of a 3D game here, we can go to the camera and change it from perspective projection to orthographic projection, and then just move it out a little bit. So give it a bit bigger size. Maybe it's a bit too much. Let's go for 7. Position is okay. So we can start it. And we see nothing. So what do we want to achieve? We want to achieve that the ball is flying around, and we can move the pedal, and in the end we want to have the bricks here at the top, which vanish the moment we hit it with the ball. So let's first go to the ball, give it a name, ball. So I want to do that with physics. To apply physics to an object, we have to give it a rigid body. And you can see that when I start this one now, the ball will fall down. Why is the ball falling down? That's gravity, actually. So to start the ball, that it starts flying around, we will attach a small script to it to give it a base velocity when the ball starts flying. I double clicked it, it should open Visual Studio for me now. Didn't click hard enough. So when you create a new script on a mono behavior, which is like all of the objects inside your Unity, it will start with an empty script which has only 2 methods, as the start and the update. Start is executed the moment this object comes to life and the game starts, and update is called in every update frame. So what do we want to do? So our ball actually will have a value, and this is the ball speed. That's the speed, how fast it moves. The moment the game starts, the ball will move with a speed of 5. And to make the ball move, we need to give it a value. So we want to calculate some random direction, which we can get from the random method. Random range is calculating a random value. It's a random value between, so the range is 0 to 2, that means we calculate a value between 0 and 1. And so exactly between 0 and 1. And now we can choose. If the value is actually 0, we can have it go to the one side, and in case it's not 0, it goes to the other side. So that's the x-axis, and now we do the same with the y-axis. We give it the same, and then we can apply this to the rigid body that we put on the ball. So we get the rigid body component, and we can set the velocity on the rigid body, which is in vector 3. That is the direction the ball will be moving, and the ball is moving with a certain speed. That's the value we defined above. Yeah, excuse me, apparently I found out I'm pretty bad at writing, typing, speaking and thinking. This is I think because I'm male. I heard women are much better with that. Maybe it will get better over time. So what now happens is the moment the game starts, the ball will be moving in a certain direction. Yeah, that looks funny. Why is that? Let me think. So first of all, one thing, I still have the gravity on. I don't want the gravity because I just want the ball to fly around infinitely. So no gravity on the ball. This is not something I have expected. Ah yes, of course. I'm so stupid. Sorry. So what is happening here? As I said, the start method is called the moment the game starts, where the update method is called in every update frame. So what I'm doing now is I'm applying velocity all over every update frame. But I just want to apply velocity once when the game starts. So the ball is actually flying. In a certain direction and not changing that with every update frame. Boom. You can see moving here. Why is it only moving in this angle? What did I do wrong? Ah yeah, it's a vector 3, so I have to give also a value on the z-axis. So you can see that the ball will get accelerated and is flying around. But what you also can see is the moment it hits the wall, it gets slower. Why is that the case? Because there's friction. All of the objects, they have a standard material applied, which is just causing friction. The same is for the ball. It has some kind of drag. How can we fix this? So we can create our own physics material in Unity and just give it no friction at all, but give it full bounciness. That means when the ball hits the object, it will get bounced off with full force. So this is our bouncy material, and we put the bouncy material on all of the objects that can actually bounce. You can see that here that it now has a physics material ball, all of the walls. And when I now start the game, the ball should continuously move without stopping. Yeah, at some point it leaves the game and nothing more is happening. It's a bit slow. I want to have it a bit faster, and I defined the speed value here. I made this a public variable, and as this is a public variable, I can directly modify it here in the editor, give it a speed of 7, which is a little bit faster. I think this is a decent speed. When the game is ready at the end, and the ball will fall through the bottom, the game actually ends. This would be a game over for the player. Since we are still at the beginning and playing around with everything, I will just duplicate the top wall and move it down a bit. So we have kind of a safeguard at the bottom, so we can see that it's all flying around. Okay, so what do we want to do next? Since we want to play, you always see me looking at this screen, since I made a small sketch note stuff for me where I thought about how I want to set up the game and which components I want to have in it, which is kind of the pre-planning thing when you develop software anyway. So make up your mind some kind of technical concept, some kind of art concept. I mean, art is limited in here. Nevertheless, so you don't forget anything. So I'm constantly looking also at my notes that I created, so I don't forget anything. But next thing that we want to do is we want to have the bumper. We give it a name. We name it bumper. Don't know if there's a better name. We want to attach a script to it, so we can read the arrow keys from the keyboard and actually have it moving. Open this in Visual Studio again. Same here, empty script. What we now want to do in every loop, we want to read get axis, which is the horizontal axis, is by default mapped to the cursor keys and to A and D, which is from the WASD keyboard for gaming. We can also read the vertical axis, which is the up and down. I don't know if we need this right now, maybe later when we maybe want to extend the game, that the pedal can also move up and down a bit. I don't know if this is of any use. Don't think so for now. Never seen a Breakout game that could do that. So what we now want to do is we read the value from the input axis, and we can use that to translate the bumper. So I'm accessing the transform component of the bumper and calling the translate, and then giving in the x and the y, no z here. And since we don't want to move upwards, I uncomment this for now. Don't know if we are maybe later coming back to this. For now we don't. So reading the horizontal axis, assigning that to a value, calling the translate on the bumper, and we should be ready to go. Oh, I forgot something. So first of all, we want to give that bumper a speed as well. Starting off with 5 again. So we're translating this with speed, and you modify that. Since we are in a constant loop, we're also modifying that with the delta time from one input frame to another. So let's see. Unity compiles, starting the game, and we should be good to go to move the bumper. That's a bit slow. I'm not able to catch the ball, so we bump up the speed here. Okay, so you can see I can move the bumper, but I can also move it anywhere. We want to avoid that. So we give it some borders. We can move that on the x-axis from left to right. So we want to limit that to min x value and to max x value. So just checking inside the game, let's move the bumper. So that would be -5, +5, kinda here, to have some even values. So we start off with that. And now we want to lock the position of the transform. So we can call the transform component. We give the position, which is we cannot so in theory what I want to do is I want to take the x value and limit that between the -5 and the +5, but those values, the specific x, y and z on the position, they are read only, so I need to assign the new vector to it. Let's make it old. Some small values. I'm lazy. So we want to assign the original position x, y, z in here, but the x value we want to limit in a specific range. So for that we can use the math library and use the clamp method. As you can see in the clamp method, it gets in a value and you can give in a min and a max, which is exactly what we want to do. So min x, max x, clamped. Coming back to our game, playing it. And broken. Why is that so? Let's look at the console. Nothing. Why? Let's check what I'm doing here. Position. Clamping that between the... Good. We also should write a -5. So we perfectly locked this one on the 5, +5. Moving that back kind of to the center. So start over again. Moving the bumper is again not working. Why is it not working? Because I already started the game and he took the starting values and already wrote them in here. So modifying the source code doesn't have too much of an impact. Basically no impact, because the values were already written in the editor. So okay, now I'm locked. I can only go up until here and here. This is level 0 of Breakout. I can move a bumper, I can move a ball. I don't have any bricks. So let's get some bricks. The playfield is a little bit small. When I imagine I will place some bricks up here, then there is not much space. So let's make the walls a little bit bigger and also try to organize a little bit in here. So we have the walls. This is the right wall. This is the top wall. This is the left wall. So start cleaning up a bit here, move that into the walls. And make it a bit bigger. Let's give it a 12. Not 112, only a 12. Also the right wall, give it a 12, then we can move the top wall further up, which gives us a little bit more space in here. Move the bottom wall down. That's the bottom wall. Why did they move at the z-axis? Let's close the gap in here. So we have more playfield. I also moved the bottom wall outside of the game. So the moment the ball would be hitting the ground later, we could call this a game over, but you don't see that there is actually a wall. Let's get some bricks. So for the bricks, I make them the same size as the bumper. So I have a brick here. We already start organizing them in a bricks folder. And let's check the left wall. Let's get some clean values here. Make the reset this one to 0. Make this -5. This 0. -1. Make the right wall. That's a bit small. -7. Right wall. +7. The top wall. 0 and a 5. Was it a 6? It's a 6. And also the bottom wall -7, 5 to give it some space. We can also go for, don't make the gap too big. So I need to look up why the z-axis actually changes. Resetting the bricks, reset the brick. And then, oh yeah, that was too much of a reset. That was a 3 and a -5. And let's align that nicely to the top, which is -4 and a 4 here. We can duplicate that using Ctrl D, make that 0 and a 4, duplicate that, make it a 4 and a 4. Then we can take all of them, duplicate them, and then we just move them on the y-axis down to 3. This was MySQL. And then moving down to 2. So we already have some bricks here. So you play the game. Okay, you see what I did here? I actually duplicated the bumper, and with that I duplicated also all the bumper scripts. Which is not what I wanted to do. It was a nice effect. Anyway, so I'm going to remove that script. I will shortly show you how we can create a prefab for a brick, so we don't have several bricks flying around here and always to modify them one by one. So what do we want to do next? Let's say we make the destroying of the bricks. Yeah. So let's give those bricks a script, but before we now start attaching the script to every single one of them, I will first remove all of those bricks again. Then we just apply the new brick script here for now empty. And now we can make this brick a prefab by just moving that around here. That has the advantage, the moment I want to change something on the brick, I just need to do that on the prefab and it automatically applies to all of them. So just setting up my game again. So the brick script. What do we want to do? The moment one of those bricks collides, so there is an on collision enter. The moment we have a collision entering, we just destroy the game object. This is pretty simple. Later you might want to do it differently. Maybe maybe just disable them. Makes it easy to reset up the game field. But also you would be able to count later or just have access to the bricks. Well, I already loved that on the Pong game. At some point you end up in a weird scenario where you have no control over the movement. You are just stuck in a specific angle. We can maybe later fix that, but this is not what we want to do for now. So we have the bricks and a pretty boring and not so colorful game. So I just quickly show you how to create a material so you can color the game. So we start off with some basic colors. We take a blue, and what do we make blue? The bricks. Ah, yeah, and here's the prefab coming. So I just applied the blue one now to one of the bricks, which is this one, and now I can take the override. It's showing me what's the difference from my brick to the prefab is, and then I can just apply. It's written back to the prefab, and all of my bricks will get blue. We also want to have red material, which is my ball. We want to have green material. This is not green. I'll change it. My green material, which is my bumper. And what color does it leave us with for the walls? Gray. Let's make gray walls. Boring, but grey. Let's make it this. So we already have a nice and colorful game now, with bricks that get removed. What next? Few things that I still want to do is, first we need the game over. So the moment the ball is hitting the bottom wall, we want to have the game over. Second thing is, normally the ball does not start flying the moment you start the game, but you have the possibility to hit space and then the ball starts flying. And let's put some basic UI around that. So we can have a high score, we can have a timer running that shows you how much you played the game or how much time you played the game. And we want to have a text telling you, hey, game starts, please press space to get the ball flying, and when the ball hits the ground and you're actually game over, we want to show that you're actually game over. So start with the easy one. We take the bottom, we added the bottom script. And same thing here, on collision enter. When the ball actually hits the bottom, we just destroy the ball. So there are two things now I want to show with the collisions. So in theory, so in our game we only have the bumper moving from left to right, and we have the ball moving in the game, so we know everything that is colliding is actually the ball. But to be sure that what you have actually is a ball, you can ask on the collision, and you can call the get collision.gameObject get component, and you can ask it for a ball. That is because our script that we attach to the ball is actually the class ball, so you can ask it for a class. If you can find the component ball, then you will actually have it here. Otherwise it's null. So you can ask if ball is not null. Then you destroy the ball. And same is for the bricks. We do the same. So we actually do check the collider. Just imagine later in the game you want to have some gadgets falling down. When you destroy a brick, it might spawn a gadget. Might be some extra bump, might be extra ball, might be health or whatever. And you don't want the game to end if one of your gadgets is hitting one of the bricks or is hitting the bottom. So you actually do a check on the colliding object and check if it's actually what you wanted. So we start the game, and what we should see is the game is no longer coming back from the bottom. It hits the bottom, game is over. So that was this starting, yeah. So when the game starts, we were looking at the ball here, you could see that the ball is directly started to move, but we want to ask it for space. So in the update loop, we can ask if input dot get button is fire. No, it's not fire, it's jump. I will show you in a moment where this is configured, just in case you haven't seen that before. So we make us a method here So when we call accelerate, we actually accelerate the ball. And we need to remember if the ball is actually moving. So if we hit the jump button, we want to accelerate the ball. Quickly show you something why I put the moving check, or why I wanted to start with the moving check. Because if you actually, so now you can see nothing is happening. When you hit the space, the ball starts moving, and the more I hit space, I accelerate it every time. This is not what we want to do. So when we accelerate it, we just remember that the ball is moving now, and we only do this check if the ball is not moving and we hit the space button. Then we accelerate it. So we have the death on the bottom. We have starting the game with space. And now what I also have seen, I wanted to do that. I've seen that in other Breakout games, that the brick actually can have a health. So we give it a brick script. We already have a brick script anyway. Remove component. So we have the brick. We give it a health that is an integer value, and we give it a health of 3. That means I have to hit it 3 times with a ball before it gets removed. So what we do in here, when it actually collides, we take the health and just decrease it by 1, and only if the health reaches the bottom, then we do destroy the game object. So you can see, have the script now has the health, should be in every, yeah. And now you can see when we play the game that I actually have to hit the brick at least 3 times before it gets removed. So what is not so nice in here, you can't see actually that you have hit the ball. I thought about that already up front, what we can do here. In other games that I've seen, it actually changes color. And I thought I just want to have it more lighter. And we can achieve that by modifying the alpha channel of the color. So we can get the color from the renderer. The one is this. Oh yeah, we need to get the component. Get component is the renderer. On the renderer we can ask for the material, and on the material we can ask the color. And then we can modify the alpha, and we just halve it. So every time we hit the ball, we just reduce it constantly. And then we can write it back. Which will then constantly decrease the alpha value. So there are 2 things now. We don't want to have, every time we have a collision enter, we want to read the renderer. Also not twice in one method, that doesn't make any sense. So the least we should do is read it outside just once, and then we can use it here, but the best is actually to use the start method and just give it a variable. and then in the start method assign the value here, and then we can use it here. Saves lookups, especially when you do something like this in an update method. You don't want to request every component all the time. So just one small thing we need to do is the material we put here, the blue material, is a normal or opaque material. We need to have it transparent so we can actually modify the alpha value. And you can now see when the ball starts moving and hits it. Damn it, I suck at this game. But you could already see the effect. It hits it and it gets lighter. Damn it. Okay, I have to make the pedal faster. So what do we have now? We have the bricks, we have the ball, we have the bumper. We can move the bumper. The ball is moving. We have the walls around that just keep the game field. We have the bottom. We can hit the bottom. The game ends. We can hit the brick. The brick gets destroyed. We have a brick health. We can modify that per brick. For now, everything has health 3, and we now want to put some UI around it. So UI is all on a canvas, and we want to put in the canvas a text element which says press space to start the game, and we want to have a game over. So we start with the start screen, and the start screen is telling you press space to start the game. This is now pretty small. We make it a bit bigger, bump it up to 48, and white is hard to read, so we make it black. It's also more ugly. Make the text box bigger, and now some nice thing about the canvas, we can put a canvas scaler on it. So instead of having a constant pixel size, we can have it scale with screen size. That means if you have a bigger screen or a smaller screen, that's the wrong one. So depending on which aspect ratio you have, everything will scale with the game. But to have proper scaling, you also have to write the size you're actually developing the game in. And if you're then going to some other aspect ratio, it will scale with the screen. Now we take the start screen thingy and actually center it. Then we want to have a game over screen. Or we can duplicate the start screen actually. Just name it end screen. Have a game over here. We don't want to see the game over screen at the beginning. We only want to see the start screen. When we start the game, we don't want to see the start screen. It should get away. So we need something that manages the game. And we do that. There are now good ways and bad ways, and there are easy ways, and for this example I go the easy way. So I create myself an empty game object which I would name the game manager. The game manager gets a script. And the purpose of the game manager is to maintain our objects. So what the game manager will have is a public game object, which is the start screen. Linked to it, it will have a public game object, which is the end screen. And since the game manager is now responsible for maintaining the game, it also needs to accelerate the ball. So when you hit the space, you will remove the start screen and you will tell the ball, move now, so that it can maintain both of them. So what we will do is we take the ball and we need to make this a public method now, the accelerate. Since the ball no longer needs to know about that, we take it away from here. And copy over maintaining the game state to here. Rename the flag. Actually make this a ball. And then we can call on the ball accelerate. If the game is game running. So if game is not running, we are allowed to accelerate the ball. We set the game to running. And what we also do is we take the start screen and deactivate it. So you hit the space button. That reminds me that I wanted to show you where this is configured. You hit the space button, we accelerate the ball, set the game to running so you cannot accelerate it twice. And then we hide the start screen, which previously was telling you press start to play the game. So we go back to the game, fix compiler errors, is not accessible. Didn't I make this a public one? I forgot to save the file. So we can see the start screen, we hit space, we forgot something, object reference. So we have the game manager, we have those objects, and we now of course need to link them. So we have the start screen, we have the end screen, and we have the ball. In a professional scenario, you wouldn't do those hard linking stuff, you would use dependency injection or a object repository where you can look up objects. You maybe use a message bus or signals to connect all those components, but this is a prototype. We want to have it fast, we want to have it easy, we don't want to put in an extra piece of software just to make this happen, so we use the hard linking here. And before I forgot that again, when you go to the project settings, you have the input settings here. And this is what I'm using, is the horizontal axis. You can see it's either the left or the right key, or alternatively the A and the D. And we also use the jump, which is the space button. Doesn't have an alt key defined. Okay, so go back to the game. When we start the game, press the space, ball accelerates, start menu vanishes. Damn, lost. When we lose, we want to see that we lost. So we want to trigger the game over. How do we do that? The ball actually hits the bottom line, and we have a collision. And the collision needs now to trigger that the ball gets stopped. We already have that, but it also needs to trigger the end screen. we don't want the bottom to know the end screen. What the least or the most we should do here is propagate the game manager. And I do the ugly way. We can start another discussion about if this is a good one. But I will use the singleton pattern here now. So we make the game manager public static instance variable thingy, and when we awake the game manager, we write that on the instance so we can access it actually from the outside. So we can take the bottom, and when the game and the ball is destroyed, we can call on the game manager. As I said earlier, normally you would do something else, either injecting the game manager or using signals, using a message bus, whatever you want. Everything is better than what I'm showing right now. If you're working in a professional project, small prototypes, go the easy way, go the fast way, but also keep in mind to throw away your prototype before you make it a real game. So I want to take the game manager and tell the game manager actually, hey, this is game over. He doesn't know about the method, so we actually generate that in the game manager. And what is the game over doing? It's taking the ball and destroys it. This is what we are currently doing inside of the bottom. What's this? We created a static method because we directly call it in the game manager. But we now we're coming to the ugly part of singleton. You can easily mix these things up. So we want to have that public method, of course, public normal method. So we destroy the ball. This is what we currently do at the bottom. So we can remove it from here, since the game manager should be responsible for maintaining the game state and not the object itself. And we want to take the end screen and set it to active. So when the game is now over, it triggers the screen, the ball stops, you know you lost. The text is a bit off here, I forgot to center that one. Also for the end screen, center it. Should look better now. We could also think about moving the destruction of bricks to the game manager. But for the bricks, I would be actually okay to have the bricks handle their destroy state. But what we want to do is, when a brick is destroyed, we actually want to count a point for that. So we take the game manager and tell him that we destroyed a brick. And when we destroy a brick, we just take the score, increment it by 1. Score will just be a private field in here, an integer. And every time we destroy a brick, we bump the score up by 1. But we also want to show that somewhere. So we take another object on our UI, which is again a text object, and this is our scoreboard. Our scoreboard at the beginning shows 0. It also has a black color, it's easier to read. And we make this one to the top. You can see that here. As I said earlier, we also want to have a timer. We can implement that later. This one is stuck on this end, and it will show the running time. So we have new UI objects here. So we also want to update the scoreboard. The scoreboard is a text mesh pro, I think it was UI. Text mesh pro GUI, I think. Which is the scoreboard. And what was the import? Using TMPro. Text Mesh Pro UGUI. That's the proper class. So we have the scoreboard, and the moment we destroy a brick, we take the scoreboard, take the text, write the score on it. So we can take our game manager, tell them where to find the scoreboard, press play, start to play the game. The moment you destroy a brick, you can see that the score is counting up. I lost again! Game over. The timer. We want to have the timer running up, just to show the time. We can do that in the update loop. So we have the timer constantly ticking up. So we have to have that in seconds. So the update loop is called in every update frame. That does not necessarily mean that this is actually every second. So we need to, when you start the game, we need to take all the delta times and sum them up, which is a fraction of a second. So we need a variable which is time running, starts with 0, and while we are running we can take the time running and add the time delta time to it, and then we can just take this time divided by 60. So we can take the timer dot text is equals time run divided by 60. Again, the to-string thingy. So it will every second it will count up by 1. We forgot to link the timer in the scoreboard. And this should only be happening if the game is running. Otherwise we're already counting the time. Even if we are not playing. So another thing is that you saw that we are actually having fractions. This is because the delta time is actually a second. So we don't need to divide that by 60. But you also saw we wanted to display the minutes and the seconds as a running timer. So we can take, let me think. So first of all, at the beginning, the minutes is the timer divided by 60. And then we need the time running, we'll do 60 for the seconds. I think yes. So we that needs to be an int, so we need to cut away. Can we call to int on that? No, we can't. Let's hope it's working this way. Let's see if I did a mistake. Timer's not running while we're not playing, this is good. When we start to play the game, that is what happens. Why is it happening? We need to cast it to an int. And we also need to cast the seconds to an int. That looks better. We want to have some formatting here actually. For the first... I figured that one out later. I'm not that good with formatting in C#. So what you've seen here in the first, up to the first 10 seconds, we didn't show a leading 0 here. Which is okay. We skip that for now. But you also see when we actually lose the ball, the timer needs to stop. Why is the timer not stopping? Because if we have the game over, we actually don't set the game running to false. When the timer is false, it stops here, the time running will stay as it is. Stops. I saw that I have an exception here. Object reference is not set to an instance in the game manager. Online 45. Is that an old one? Oh, this, I love it. Okay. We also want to have a wind screen, I think. We're also, I think, quite close to the end now. The wind screen is... I duplicated the start screen, so is off by default. You won the game. So we give the game manager a windscreen. What we also want to do when you have one, we set the game to not running, we destroy the ball, and we need to check when you actually have one. How do we do that? So when the scene is set up, we need to know how many bricks we have. We could now also link all the bricks into the game manager, but I go in an easy way here now. So we just have a variable which is the brick count, and in the awake method, so when the game actually starts, we can assign the brick count, and we can use the game object static helper method to find objects of type, and we can search for brick, and then we can query the length, and in the update method we can have a check. So if the score equals the brick count, how did we name the method? Game1. Since we only use it here, we can make it a private method. Let's see if I can win the game so we can actually check if it works, since I'm sucking at that game so much. See? Game over still works. Oh, there's a missing reference. Where are we trying to access the ball? I know. We hit space when the game was over, but so we getting here. We are setting now when we lose, we set the game to not is running, and then we can trigger the jump again and it tries to accelerate the ball. But since we destroyed the ball, we can no longer do that. So it's not only is game running, but we also need to check. We only do the game logic in here if it's not game over, and if we lose the game, we set it to game over. Why do I actually differentiate between game over and game running? So in theory we could have a pause method when you hit escape, for example, or P or whatever, that the game is paused, then we can set the game loop to not is running, but we don't want to have it game over because we want to unpause it and then we want to continue. So let's try if I can win. Better testing actually would be to only work with one brick here. That's a better start. Looks like we can win this one. I can still remember how much I loved these games back then. On the C64, later on the PC I was also playing it. There were also some nice tricks possible. Looks like I'm stuck now. You could move the pedal while the ball was on it, and you could give it a different angle. Game over, but nothing happens. Why? I think I forgot to also assign the win screen in the game manager. Good. Win screen goes here, start screen goes there. But we are still trying. Why is the ball? He's now complaining that the ball is actually destroyed and that he can no longer access it. That means that somebody already destroyed it. Because we only do this one once. It was still doing that in every loop. So we only do the game one check if we're not game over. Afterwards we are out of the loop. I'm trying to win again, and I also take a small look at my cheat sheet. I think I've done everything that I planned for this. I so suck at it. Nice would be actually, do I still want to do that? Oh, it's already nearly 1. If you lose the game, you should get the possibility to press space to start the game again. I'm not doing this today. I actually planned a follow-up session on that one to show you a little bit of what I mentioned earlier, how you can separate the logic better from what is happening here, from the game manager stuff. Maybe use dependency injection, maybe use signals or a message bus. I haven't decided yet, but I also wanted to show you how this can be a bit nicer, so you don't just do it the ugly way. So I won the game. I scored 9 points for 9 bricks. It works actually. It took me 46 seconds, and that's the game over. I will put this on GitHub, I think, for anybody who wants to try out, wants to have a look at this, or maybe wants to check it later. Make this our breakout game. And yeah, I will plan some stream for later to go a bit into how can we avoid the game manager like I did that now, how can we avoid all this hard linking. We also didn't move the the input handling to the game manager. We moved all of those ball handling or game over start to the game manager, but actually also the game manager should, or there should be an input manager that reads the input and then controls the pedal with it. And the bricks maintain themselves, but maybe the game manager should do that. But for now, I think that's it. I will later update with the GitHub link. And if you like also games, you can check my other videos. I did live streams with the new Warhammer 40k game, Adeptus Mechanicus. It's in German. Maybe I do the next ones in English. Haven't decided yet. I hope you had some fun watching. And if you have any questions, put them in the comments below. Let's talk about the solutions I did here. What would you have done different? What do you think I should talk about when I do the next session on how we can improve that? Sorry for me starting off German this video. Sorry for being a bit puzzled at the beginning. I think I kinda made it better at the end. Now I'm already confused, but I'm also getting tired. So see you later. See you on the next session. That's it. Thank you.